Hello, dear friends. In the previous videos, we learned about what is LangChain, and also we discussed some of the components of LangChain like model, and also we discussed about prompting and also chain. So in this video, we are going to see about the next component of LangChain, that is memory. So this already we know LangChain is a Python framework which helps us to integrate LLM with other components with like a memory, tools, agent, like a model, prompt, and all these things. So here memory is very, very important. This is the fourth component we are discussing. So it could, because of the memory only, it could able to remember the previous conversation. So if it is remembering the previous conversation, then only it could able to give a better solution or a result or a suggestion or whatever may be. So without memory, if you see A, treat every question as a new one. There will not be any continuity or no personalized data it can provide. But if it is remembering the conversation, then it should remember what we said previously. And when I ask a question or when I ask a session, then if, for example, in the beginning, I would have said, I'm Roshni, I am interested in generative AI. So later on, if I ask some project suggestion or title, since it remember that my area of interest is generative AI, so it will give some topic related to generative AI because it remembered my previous conversation. So that is the importance of memory. So with memory, AI can remember all the previous messages. So it gives a human-like feel, so that we can able to get a better results. So it will make the chatbot feels like human. So the memory is attached, you can attach the memory with a chain or with an agent. So past information is passed along with the every prompt. So if the prompt means that's what the input we give. So when we attach this memory with the prompt or with the chain or with the agent, it will understand what happened in previously. So accordingly, it will be answering the question. So the LangChain provide standard memory interface, database integration, ready-made memory patterns, all these things are available. So now we are going to discuss about the types of memory in the LangChain. Now you would have understood what is the purpose of the memory in the LangChain. So to remember the previous conversation, so let us discuss about its type. The first one is conversation buffer memory. So this is one type of memory present in the LangChain, which can be, as we discussed, it can be attached with prompt or with agent or with a chain. So when we attach this memory, it will understand the entire conversation history. So and it will send it to the LLM when we every time when we ask for a response or when I give a prompt, this entire conversation will also be attached with my prompt when I use this conversation buffer memory. So it will keep all the users' message, very detailed context will be there. But the problem is since it is storing the entire conversation, so it needs lot of memory space. So the cost is higher and the response is lower. So where we can use this conversation buffer memories for shorter conversations we can use, because for short conversations we can store all the conversation happened before so that it could able to do better. So here is an example. So if you consider this is a conversation, I'm saying my name is Riya, nice to meet you. This is my conversation. So in the memory, all the complete conversation will be stored. So on every new question, the full chat history is sent again to the. So if I'm asking a new question, this full conversation memory will be sent to the prompt as a prompt to the LLM. So, for example, later after see here, I'm saying I am a first year student. Then I'm saying I'm interested. I'm studying data science. Later, the student may be asking, "What is my name?" And my field of study means it will easily understand since it has conversation buffer memory. We know this conversation buffer memory is attached with the prompt, no? So when I ask a new question, it may be because the memory is attached, it can easily understand your name is Ria and you're interested in, you're studying data science. So since all the past memory is available, it can able to understand. So that is about conversation buffer memory. The next type of memory in LangChain is conversation buffer window memory. So that is what the new thing, window memory. So what it is, Lanes, it will remember the recent messages. So instead of the entire chart, recent message means how many recent messages you want to remember, that we can give last n interactions or conversation. For example, if I am saying you remember last 10 conversation, means it will remember only the last 10 conversations. If I say remember only the past 5 conversation, means it will remember only the past 5 conversation. That is what window. So I can specify the size of the memory, how much it want to remember. So this conversation buffer window memory is suitable for long chat with limited context needs. So if it want one limited context information and it is a long chat, you can go for this conversation buffer memory. So here I have another conversation with user and with AI. And now I'm specifying the window sizes too. So it will remember the last two conversation. This is the last two conversation. I want to learn generative AI, and it says that's an excellent field. So all the other will not be there. So older messages like name, department will be discarded. So only the last two conversations will be there. So if I'm asking what is my name, means it'll say I'm sorry, I don't know the information right now, because the earlier message is out of the window, because now we gave the window sizes too. So the next type of the memory is LangChain is conversation KG memory. So what is KG? Is knowledge graph. So what happened here in this is, instead of storing the entire conversation, or instead of storing only the last two conversation, how what this conversation KG memory will do means it will extract the important entities and the relationship and store the facts instead of the complete raw text. It will store it as a um, facts. So it is more structured and it's also so intelligent. So it is better for reasoning. Whenever you want to find a factual conversation, you can go for this conversation KG memory. This is knowledge graph memory. So here is an example. I have some conversation between user and AI. It says I am Dr. John. I teach data science at Carnegie University. Then I have then the AI is saying nice to meet you, Dr. John. And later it is saying user is saying I'm preparing a course on generative AI. So this is what the conversation is. So how the conversation KG memory store this conversation, like instead of storing the all sentence, it will extract only the entities. That is the key fact, and it find the relationship, and then store that as a graph. That is what the knowledge graph. So here the important keywords are okay. First we have the first important keyword is John, and what is the relationship? That is teaching, and the next entity is data science. So then again, what is the relation between John and next one is John, and then he works at where the next relationship John with works at Carnegie University, and then next John is preparing generative AI course. So there is like a graph. So John is teach data science. So John works at Carnegie University, and John preparing generative AI course. So this forms a knowledge graph of a fact. So if I ask anything about John, it will quickly retrieve the answer and give. So John, what does John teach means? It will quickly say data science. So that is what about conversation KG memory. So here is an example for that. So the knowledge graph here. So Dr. John teaches data science, he works it, and here preparing. So all this information is stored like a graph, knowledge graph. So we have all the entities as a nodes, and entities maybe they can be a noun like person, thing, place. All these things are the entities. It just means the relationship between these entities with the verbs. So it will find all the noun as entities and the verbs as relation between the entities with that particular action. And the thing like it is as a connection between the label arrow. So this is how it will be stored. So another way of storing this knowledge graph is triplet form. So here it is like each fact is stored as subject, relation, object. That is triplet. So it's a John teach. So in this instead of knowledge graph, it can also be stored in this format, triplet form. John teach data science. John worked at Carnegie University, something like this. So this collection of triplet is the knowledge graph. So this is what the next memory. The next one is so which subject do I teach with? It can easily get it from the knowledge graph and it will answer. The next one is entity memory. So entity memory means here it is going to remember the specific informations. So entity means we already know place, name, objects, and the important facts about this entities are you stored them as a database. So that is what entity memory. So, store the important facts permanently, and it will remember the entities and the user preference. So, it will be suitable for large applications and long term agents. So, here is an example. So, here I have a conversation and how the entity memory store all this information. So, entity means we know the important name, place, all, and the facts are stored. So, here the entity is Dr. John. So, the information about the Dr. John. What are the information about the facts about the John? The name, profession, subject, organization. So all these things are the fact about this entity. So this is how the entity memory will be storing. So this facts are stored in the database. So not as a temporary chat memory, but it will be stored in the database as a permanent data. So it will be available. So that is what the entity memory means. So we find the entities, and then for that particular entity, we have to find all the related fact about that particular entity. So here is an example. So even after we restart, it will remember all these things. So who is who, what is the fact about the person. So it is for useful for a long-term personalized information. You can use this entity memory. So entity memory helps LangChain remember the important facts about a people or a place or an object across multiple conversation because it is using database to store the information. So the next one is conversation summary memory. So from the word itself, you can understand store the summary version of the conversation. Instead of full message, it will just take the summary. It's like when we have a meeting, we will take notes of the meeting, right? Similarly, here all the conversation is just summarized. So it is like a meeting minutes. So what is the advantage? So since it is not storing the entire conversation, it saves the space. It retains the key information because it's just taking the summary, no? So, but what is the disadvantages? Since it is only taking the notes, sometimes some fine details may also get lost. So that is a disadvantage. So here is an example. So here I have a conversation. So a conversation summary memory, it will take only a summary. So this is the summary of this complete information. So here is the summary. So Ria is a second year data science student interested in machine learning, generative AI, and it's seeking project suggestions. So this is what the summary of this complete conversations. So based on the enter suggested project title means, so from this summary, it can understand, okay, this Ria is interested in machine learning and generative AI. She is a second year data science student. So according to this conversation, it will suggest a new topic. So if it is not remembering, if she is asking such kind of question, it cannot be able to answer it. The next memory is vector stored memory. So vector stored memory is an important one. It stores the past conversation or information as a vector format. Vector format means we know already we have discussed it's a numerical representation. So the system can easily search and retrieve the relevant memory whenever we need. Since it is a numerical format, searching and finding answer can be done in a very efficient manner. So it will store the conversation in the numerical format. That is, we call it as embedding. For smart retrieval, it is like a searchable memory bank. So how does it work? Means that it will convert the conversation into vectors. That is a numerical format. Store it in the vector database. So retrieve past the information whenever it is required. So what is the advantages? It is scalable, searchable, efficient for long conversation. Since it is in the numerical format, searching anything, it's also be very efficient and it is useful. So here is an example. So here I have a conversation. So how the vector memory works internally means each important message is converted into vectors, that is numerical format. For example, here I have interested in deep learning project. Here it is like no interested in deep learning project and interested in healthcare AI. So that was a conversation. So these vectors are stored in the vector database. How does it work? Means the system convert the question into vector. So let's see an example. So here is a conversation. So suppose the conversation this other conversation you consider. So it will convert the text into vectors, which means embedding. So the LLM embedding model converts this sentence into list of numbers that represents the meaning. These numbers are not random numbers, but it has some meaning for it. For example, for sentence one, we have deep learning project. So for the deep learning project, this is a numerical representation of it. So here we have only given four numbers, but in reality, it has 384 numbers and 768 numbers are 1536 numbers. But the idea behind, the content behind, or the meaning behind it is same. and the second sentence is healthcare IA. So it will be converted into numerical format. So the store vectors in a vector store. So this vectors is now stored in the vector store. There are vector library or there vector database are all there. So this numerical format will be stored there. So I'm interested in deep learning project is converted into this numerical format. Similarly, want to work on healthcare related AI means this is converted into this numerical format. So this is similar to storing key vectors and the value original text. So this is also very good. So when a new question is now coming, so already we have vector for I'm interested in deep learning. I want to work for healthcare related product. So now there is a question. So what does the question means? Suggest a project based on my interest. That is what my question. So this question is also converted into vector. Now this vector will be so it want to give the answer for this question, right? And it is also in the numerical format. Now it will find the similarity between this given vector with the already stored vector. So which values are very close to both, very close to this question. This question. So that will be the answer. So the query vector is very close to both S1 and C. What is the and first one 0.12, 0.1 to 0.10. So and here it is 0.11. So both are this 0.11 is close to 0.10 as well as 12, right? So this is how it finds a similarity. So those two memories will be retrieved from the database and then accordingly it will respond. So it says suggest a project based on my interest means, so this both will be retrieved. So it can understand, okay, they are interested in deep learning project related to healthcare. So the LLM will respond. You could work on deep learning based healthcare projects such as medical image analysis or disease prediction. So in this area you can work. Since it know its previous history, which is in the numerical format stored in the vector database. When a new query is come, that is also converted into numerical format. Then this numerical format is compared with a number. It is very easy, right? And you can also easily find the semantic search and give the better results. So how LangChain uses the memory is automatically injects, as I told in the beginning. So this memory can be automatically attached with the prompts. So it can able to manage the memory updates. So it will give the past context, relevant past context, so that you will get a better results. So developer doesn't manually handle this this conversation history. It will be automatically injected with a prompt or with a chain or whatever it may be. So here is a summary. So conversation buffering means short conversation. So conversation summary means it can be used for long conversation. Vector storage means whenever you want to knowledge retrieval kind of work, you can go for it. So here is a complete conversation about all different memory types present in the LangChain, which we have already discussed. So we can go through it. So conversation buffer memory means it will store the complete conversation. Window means it will store end messages. Summary means a summary. KG means knowledge graph, stored all the entities and relationship. Entity memory means it will take an entity and find all the relevant attributes. And the vector storage means it will find the vectors of the interactions and then it do the semantic search. So vectors mean numerical format. So this is about the memory. So let's see about a small implementation of this memory so that you will get a clear idea. So as we discussed in the previous video, so similarly you have to import the necessary LangChain module, and then I have developed the Grok API key using the freely available API key given by Grok, so that you can access to the LangChain, Llama models. So here are some of the important header files we have downloaded. So for chat prompt, template, for memory. So all these things are imported. So now I'm creating an object. So where we are going to attach this Llama 3 model, and then I am having a prompt model. So where I have using the chat prompt template from message, I'm giving to the system, I'm giving the information as you are a helpful assistant. So that is what the condition I'm going to give. Then here next I'm going to the human input is the input which we get from the user. And then here is the prompt. So already we have learned about how the prompt is, what is the importance of prompt. And then here is a chain. This also we already learned. Here we have giving only two chain. One is prompt and the LLM. So prompt is the input and what is the LLM model we are going to give. So here we are using Llama 3 and this is my prompt. What we are conveying in the prompt, I'm saying to the system that you are a helpful assistant and the user input will be given here. So then going to create a session history. So here we are going to attach the memory we are going to use. So then the next one is here we are going to make a chain. So the chain here is already prompt and the LLM. This is the chain which we created. Along with the chain, going to get attached this memory. So here I am going to use in-memory chat message history. So along with that, this is also attached. So now, so we have a chain, we have a prompt, we have a chain. This chain is attached with the prompt now. And the memory is attached with the prompt. So this is the memory where we are saying it here, and that is attached with the chain. So chain contain the prompt and the LLM. So along with the prompt, this memory is now attached so that you will get a clear output. So the next one is configuration. So here I am saying about the configuration. So config is what is represented in the dictionary format. See here I am going to use first I am going to do a conversation about the user one. So that is what. So whatever I am going to do conversation, that will be attached to the user one session. That is what the session ID. So now whatever conversation we are going to do, all this will be attached with the user one. So here I am calling chain with memory. Chain with memory contain what? All this chain. Along with that, we are attaching this memory in shared memory. So that is what the chat with memory. So along with the prompt and LLM, we are attaching the memory. That is what this line. And invoke means already we have learned. Invoke means going to give the prompt and getting back the result. So input I am going to give is hello, and this configuration details also given, which means I am saying all the conversation done now is related to user one. Similarly, I'm also saying input, my name is Rosh. Then I'm asking what is my name. So since we have attached this memory to the chain of prompt and LLM, so it is asking, it looks like we have started a conversation and you have introduced yourself as Rosh. So since it is remembering the previous conversation, it could able to answer for it. Here is another one. Here we are creating another new session ID. Here the session ID is for user one. Now we are creating another session for another user called demo user. So again here I am going to get the input from the user itself, and until the user is pressing exit, I am going to attach. I'm going to call the chain with memory. Along with that, I'm going to get the user input, and also I'm attaching the configuration. So so the response is here. So response dot content, the response content alone is got and printed here. So here is my conversation. I'm asking hello, this is Roshni, as I'm typing, and the bot is responding back. And then I'm asking about the LangChain, it is responding back to me. So that is what the prompt is. So it is asking the input prompt and the configuration. Okay, so this is how the memory is used. So what is the important thing we have to remember here is, along with the chain, we are attaching and saying what kind of memory use. So get session history is where we are specifying about the particular session ID, what is the memory use, so that whenever I ask any query, so it will, this memory will be attached no already, so it will give you the proper result. So I hope you have understood what is the importance of memory in the LangChain. So to make a better generative AI application. So thank you for listening. God bless you.